Going on, everyone? Today we are looking at Leetcode number 438, find all anagrams in a string. This is another question, another string question that is frequently asked at a lot of companies, so I highly recommend being familiar with it. It will show up out in the wild, and definitely want to be familiar with this pattern. You can see Facebook has asked it a lot in the last 6 months. Amazon, Bloomberg, Snapchat, Microsoft, all the big companies like to ask this one. Okay, so let's run through it. It's not too bad. We're going to go through two approaches to solve this problem. One, we'll look at a brute force approach, and then we will look at a more efficient approach, and we'll go from there. Okay, so find all anagrams in a string. So this problem is not too difficult to understand. We have a string here, and we want to find all the anagrams of this P string here. So we're going to get two inputs, a S string and a P string. And this P string ABC, we want to iterate over this S string and find all the anagrams inside of this string that match to the P string. So here we have CBA, that's an anagram. And then we have BAC, that's an anagram. And then we want to return, we want to create a result array and return the starting index of the anagrams inside of that S string. So here 0 is the starting index of CBA, and 6 is the starting index of BAC. Push that into a result array and then return that. Okay, so that's the question. Now, some of the things to think about when you look at this is that it's not a hard question to understand, and it's not a hard question to implement a brute force solution. That would most likely be the first guess on how to solve this, and that's okay. You know, I mean, you wanna try to at least solve it first, and then worry about how to move forward from there. So now, some clues in the prompt that might be important to recognize on why a brute force solution might not work for this is, you can see here that the S and P strings will not be larger than 20,100. So you can't really get very inefficient time complexity. It's going to have to be efficient if the inputs are going to be, you know, in the 10,000, 20,000 range. Okay, and so that's another thing to keep in mind when thinking about an approach to solving this. But let's take a look at a brute force approach. So here we have CBA, EBA. Okay, so we have our input string, which is going to be CBA, okay, EBA, BAC, EBA, BAC, and then D. And then our P string is going to be ABC. Okay, so what is a brute force way we could approach this problem? We need to figure out all the anagrams inside of S that equal P. Well, a brute force would be to get all the substrings, right? We could get all the substrings in this S string, and then we could iterate over each one of those substrings and check if it is an anagram of P, right? And then we would have to somehow get the indices of where those substrings are, and then push those into a result. So for example, what we could do is, let's say we grab these three strings here, and then we convert it into a hash. We check, are they anagrams? Is that substring of CBA an anagram of P? If it is, then we go ahead and push in the ith index of where it's at. Okay, then we come over here, we do the same thing. We come over here, we do the same thing. Come over here, we do the same thing, and so on and so forth, right? And so what would our time complexity be if we're trying to do that? Well, we would have to iterate over everything once, and then for each iteration, we would have to go ahead and do an inner iteration where we have to convert it. We could either sort it, sort both, sort P and sort the substring of S. That's going to be an n log n operation. Or we could do it linear by hashing them. We could hash P, hash S, and then check equality there. Again, that would be an n operation. So both of those we could either get, if we use the sorting method, we could do n times n log n, or we could do n squared if we use the hashing method, right, for time. Okay, and what if we wanted, what about space? How much space are we going to need? Well, we're going to need new space for every single substring that we're creating, right? So we would probably have n squared on space as well. Okay, so it works, but it's not good. And when we have an input of 20,100, it's not going to be efficient enough to handle an input size of that capacity. So we want to think of something better. Okay, let's go ahead and clear this out and see if we can come up with a better solution to this. Okay, we have CBA, EBA. Oops, let me do white here. CBA, EBA. Okay, and then we have BACD. Let's go back here. BACD, and then we have ABC. Okay, this is going to equal our P string. This is going to equal our S string. Okay, so how could we approach this in linear time and linear space? What could we do? What approaches could we think about? Well, we could do a sliding window approach, right? We also know that in the input here, it says that our strings are going to consist of lowercase English letters only. Okay, lowercase English letters only. That's really important because what we could do is we could create two arrays that map to every character in the lowercase English alphabet, right? So let's say we had a P array, okay, and we had index 0, 1, 2, 3, 4, and so forth, all the way to 25. That's going to represent the 26 characters in the alphabet. And here we have the string ABC, right? So what is the frequency of ABC in the P array? Well, there's one A. We can map A to 0. That's going to be 1. B to 1. So we'll have 1B there. And C to 2. And we'll have 1C there. What we could do then is also create an S array. Okay, and just doing the same thing, 0, 1, 2, 3, 4, map all the way to 25. Okay, we're going to have an ith index that we're going to be iterating over our S string. So what we can do is we can iterate I over here, okay, and then we're going to, since we have C, we can map 1 to that C index. We move I over. Now we have B, we have 1 here. In B, we update the S array. We move I over here, and now we have 1A. And what we check is if I is greater than or equal to P dot length, right? P dot len minus 1. So if P dot len is 3, okay, and here we're at 1, 0, 1, 2, 3 minus 1 is 2, And if I is greater than or equal to 2, then we check, are these two arrays equal? Do they have equal values? Right? And they do. You can see that P array has 1 at 0th index, 1 at 1 index, 1 at 2 index, and this S array has the same values, right? And so then we can just go ahead and push I minus P dot length minus 1, so I minus 2, so I is going to be 2, 2 minus 2, which is going to be 0, and we can go ahead and push that 0 into a results array, right? And now we move over 1. We move I over here. Now we check. Before we do this, we actually want to check before that. We want to check if I is greater than P dot len minus 1, right? And if I is greater than, that means it's outside of the window range. That means we are outside of the length. So what do we want to do? Normally it's sliding window. When we get outside of the window range, we want to delete from the beginning, right? And so what we can do is whatever I is at and the P dot length is, we can subtract those two and figure out what was at the beginning. And it's going to be 0, and we decrement this C here. We get the char code for C and we decrement it in the array there, in the from the beginning, right? And then we go ahead and check again, what is I at, and is it greater than or equal to P dot len? It is, and is BAE, we're going to also have E here, so A, B, C, D, E. E is going to be 1. We can then check, are these arrays equal? And they're not, and so we just move forward. We just move I, okay? And again, when we get to that iteration, I will be outside of the range, okay? I is greater than P dot len minus 1. And so again, we're going to decrement this B here. We're going to subtract I from P dot len, and we're going to decrement B back to 0, right? And so forth and so on. And when we get to index 6, okay, we're going to find that, well, actually, when we get to index 6, 7, 8, and we run this if statement right here, we're going to also find that 6 is also valid, because at that point, P array and S array will equal each other, okay? So that's our conceptual strategy on solving this problem. Let's go ahead and code this up. Okay, so what do we want to do? We want to create 2 arrays, one for S and one for P, and those arrays are going to be frequency counts for lowercase alphabetical characters. Okay, so we can do const S array, which is going to be new array for 26 characters in length, and we're going to just fill it with 0. Okay, and we're going to do the same thing for the P array. What else are we going to need? Well, we're going to need a result over here, right? We want to return a result, so we want to also go ahead and have a result and just set it to an empty array. Okay. Now, what do we want to do? We want to iterate over our P string and calculate the frequencies mapped to each character to the index of our P array. Now, something to note here, how do we get the index A to match 0 and so forth? Well, we can use something, we can get, you can use a helper method in JavaScript called char code at, and that will give us the char code of that particular character. And what we can do is just mod that by 26, because there's 26 characters in the alphabet. So whatever the char code is, it'll throw us a number between 0 and 26, and we can mod it. We can then map that to the P array. So we can do for let I equals 0, I is less than P dot length I plus plus. Okay, and then we want to get the index, and the way we're going to do that is we're going to do our P string dot char code at. It's a built-in JavaScript method, of I, and then we're going to just mod that by 26. Okay, so char code of A, I believe, is 97. 97 mod 26 should give us 0. Okay, and so now what we're going to do in our P array, the index here, we're just going to increment it, whatever's at the index. Okay, so in the P array at index 0, we're going to increment at 1 for A, we're going to increment at 1 for B, and we're going to increment at 1 for C as we iterate over these 3 characters. Okay, so now let's go over our S array iteration. Okay, and now what do we want to do? We want to do the same thing. We want to get our index, and we're going to do s dot char code at, and here we're going to do it for I mod 26. Okay, and then our S array at index, we're going to increment that. Okay, so now what do we want to do? We want to check if we are outside of the range first. Okay, so is I outside of the range? Are we outside of the window range, our target window range? So we can do if I is greater than p dot length minus 1. What do we want to do? We want to decrement the head, right? So we want to get the head index, and that's going to be s at char code at I minus p dot length mod 26. And what are we doing here? We're getting the ith index, the char code of that, and we're subtracting p dot length from it. Okay, and then we're modding it by 26. So that should give us what is at the head, what is at the beginning of our S array. And then what we're going to do is our S array at head index, we're going to just go ahead and decrement that. Okay, so that should keep our window where it needs to be. And now we just need to check if I is greater than or equal to p dot length minus 1. What do we want to do? We want to check if, and we'll have to do a helper function here, array values equal, and we're going to do our S array and our P array. And if they are equal, what do we want to do? We want to push into our results. So we can do result push, and we want to push the beginning. So we want to do I minus p dot length minus 1. Okay, and then we just want to return our result. And let's just go ahead and code out this helper function. This is a very bare bones helper function. If you really want to check array equality on values, you would have to also do edge cases for length, but I think for the context of this problem, that's not necessary because we're only checking 2 arrays that we know are of equal length. So you can do const r arrays array values equal, and we'll have array 1 and array 2. Okay, and all we're doing here is just gonna we can just iterate over this array 1. And then we just want to say if array 1 at index I does not equal array 2 at index I, return false, else we just return true. Okay. And that should do it. Let's go ahead and run this. Let's see here. Where are we not pushing? Slight bug here. And if you can see here on line 8, we have a bug here where we have a 1. And what we want here is we want to make sure we have an I. Okay. Now if we run this code, should work. And then we can run that. And yes, we have success. And so that is Leetcode 438. Let's just quickly go over time and space complexity for this. So what is our time complexity and space complexity? Well, we saw with the brute force, our time complexity was n times n log n, because we were going to sort everything in there, and then we could get it down to n squared if we used a hash. With this, our time complexity is actually n. It's O of n. We can do this in linear time because we're just going over each array once, and then on each iteration we're just doing some constant time operations, which is decrementing from the front, adding to it. All of that is just our constant time operations. So we can say that our time complexity with this is going to be O of n time. And then what is our space? Our space is also going to be O of n. Okay, because we're going to return a result array that worst case every element, you know, could be a p. Like if p is just the same thing as s, we could have a worst case of n. And so time and space is O of n, which is pretty good. So that is Leetcode 438, find all anagrams in a string. I hope you enjoyed it. Highly recommend getting familiar with this question, and also familiar with the pattern that this is using. This is using a sliding window pattern. And so again, this is a pattern that helps you solve a lot of problems that are frequently asked. And so it's a good practice problem to be familiar with that pattern. Okay, that's all I got for this one. I will see you on the next one.